X. Okay, now, first thing we have to understand is what is E. E is the natural base. And again, it's all about that base. All right, now, what we have here is by definition that E is going to equal to the limit as H approaches 0, and we're going to consider from the positive side here, but it's of 1 plus H to the 1 over H power. Now, that's approximately equal to 2.72. Now, that may look basic enough, but I want to give you just kind of a brief overview. This is not anything that would, it's just a general idea. This is not a technical definition. But what's happening here is you've got this number in here approaching 0, right? So what happens as 1 plus H, as H gets closer to 0? What's that value in that parentheses getting closer to? 1. Now, looking at the exponent. All right, well, let me break just a second. What typically is 1 to any power? 1. 1 to the first is 1. 1 squared is 1. So forth. So 1 to any power is typically 1. Now, let's talk about what's happening as far as the exponent is concerned. As H is getting closer and closer to 0, what is happening to that exponent?
Undefined?
If it was 0, it would be undefined. But it's never quite becoming undefined. It's actually getting larger. Because think about it like this. I've got 1 over 0.1, 1 over 0.01, 1 over 0.0001. All right, so would you agree in each case that this denominator is getting closer and closer to 0?
Yeah.
So what is 1 divided by 1/10? 10. What's 1 divided by 1/100? 100, right? And what is 1 divided by, oh, that's 1/10,000. 10,000, right? Okay, so my question coming back to it is, are y'all listening? What is happening to my exponent as H gets closer to 0? How big? Infinitely large, right? Okay, so I've got some number that's getting closer and closer to 1. It's getting closer and closer to 1, which tends to make the answer be 1. But my exponent, it's never quite equal to 1. It's very, 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 very close to 1. And then my exponent is getting, the closer this is getting 1, the more infinitely large this is getting. So because of that, it's kind of a battle between going to infinity as a power and going to 1 as a base. So it evens out at approximately 2.72, which is this value E. So that by definition is what E is. Now, let's look at its derivative. And to do the derivative, I need to go back to the limit definition of the derivative, which says that we are going to say that the derivative of e to the x is e to the x plus h minus e to the x over h. Sorry, the limit as h approaches 0. Now, because of the nature of e, we're going to approach 0 from the right. Now, if you plug in 0 there, you get 1 over 1, right? I mean 0 over 0. If you plug in 0 for h, you get 0 over 0. So that means that there is a good possibility that the limit does exist, and we will say it does. So let's look at the arithmetic here. Now, if you're adding exponents, what is your original problem? When do you add exponents? What type of arithmetic problem causes you to add exponents? Multiplication with like bases, right? So I'm going to turn e to the x plus h into e to the x times e to the h. Are we okay with that? All right, now, in that numerator, I've got the product of e to the x and e to the h, subtracting from that e to the x. So, what could I possibly do here in the numerator? Can't cancel.
Take it out.
But factor it out, yeah, factor it out. So it's going to become the limit as h approaches 0 of e to the x times, what would I have here?
E to the eight.
To the h minus 1.
Yeah, all over h. Now, what's wrong?
Never mind.
You good?
Yep.
Okay. Now what happens with e to the x as h approaches 0? What happens to e to the x as h approaches 0?
It's getting bigger.
Is it constant?
Yeah, in a sense it is, because h approaching 0 has nothing to do with e to the x. So I can pull it out front. So I have e to the x times the limit as h approaches 0 of e to the h minus 1 over h. Now, e to the 0 is, starts with a w? 1, yeah. So 1 minus 1 over 0, 0 over 0. So we've got to try something a little bit different here. Now, what I'm going to do from here is go to my definition of what e is. And remember we said e is the limit as h approaches 0 of 1 plus h to the 1 over h power. So I'm going to have e to the x times the limit as h approaches 0 from the right of 1 plus h to the 1 over h power raised to the h power minus 1. Does anybody see something that happens with my numerator now that I put the definition of e in the place of e? Something happens here as far as the arithmetic is concerned.
Would perhaps the h multiply into the 1 over h and make it just 1?
Yeah. You raise exponent to an exponent, you multiply them together, right? Good. So this just becomes 1 plus h minus 1 over h. Keep going.
So it's h over h.
So it's h over h, right?
1.
Wait.
Where it's,
Over
wait, no, that's
eight.
0.
So the
Zero
x
over
is
zero.
which means
No, it's not 0. Don't make me cry.
so that means
What is h over h?
what?
1. So it's e to the x times 1, which is e to the x. So the derivative of e to the x is e to the x. That means if you take the curve e to the x, y'all listen up, this is the big takeaway from here. Whatever your y coordinate is for e to the x is also the slope at that point. So if you look at the curve y equals e to the x, here your y coordinate's 1. There you have a slope of 1. all of these y values are less than 1, right? So notice how their slopes are less than 1. So the derivative of e to the x is e to the x. Now, from this, let's do some derivatives. Now, understand this. If I have the derivative of e to the u, the derivative with respect to x of e to the u, then that answer is e to the u times the derivative of u. So it's e to the exponent times the derivative of the exponent. So it's a chain rule in its own sense. Okay? So the derivative with respect to x of e to the x squared is e to the x squared
Times 2x.
times 2x. The derivative with respect to x of e to the cosine of x is
E to the cosine x times negative sine x.
very good. E to the cosine of x times the negative sine of x.
Oh.
How are y'all with that?
You made that one?
All right. Now,
Yeah.
let's look at the derivative of the natural log of x. Can I erase what we have up here?
Yes.
Okay.
Erase it all.
Now, the derivative of the natural log of x, I'm actually not going to do the derivative of the natural log of x in terms of the limit definition of the derivative. I'm going to say that y equals to the natural log of x, and I want to know what y prime is. Okay? Well, I'm going to start this problem off by bringing in a what's wrong?
What is that scribble?
This is the natural log of x.
You better write that down.
Okay.
Y'all hadn't seen that before?
No.
I've never talked about the natural log.
No.
It's the natural log is when it's the exponent that goes with e. So if e to the q is equal to m, the natural log of m is q.
Oh, okay.
Right.
Okay, I think we
That makes no sense, but okay.
Symbol before.
Okay.
Yeah, I didn't know what that was. Like,
You just
okay,
toss
is
that
it like
symbol
a
out.
cursive
Let me
L
write
and a
that
U?
down for
Like,
your
what
research.
is it?
Say that again.
What is it? Is it like cursive L and U?
Yeah, it's a cursive ln.
Okay.
You could do it like this, but when I do that, it looks like one N. So that's the reason I do it in cursive,
That's the way you put the capital L.
because that's not the way it's done. The
Oh.
math people who came along way before me didn't let that be a capital N. I mean capital L. If I was invited to the party, I would have let it be a capital L.
Yes. And we don't have to go in cursive.
All right, are y'all okay to keep going from here?
Yeah.
All right, so here we go with this. All right, I'm going to take and give a base of e to both sides of this equation. What's wrong, Jacob? Did you have some silly milk with your cereal this morning?
Stop laughing.
I'm trying. I'm sorry.
All right, now let's talk about this. Now, I haven't done any calculus yet, and not doing calculus in this step, but these two functions are inverses of each other. So e to the natural log of x is x, and the natural log of e to the x would also be x. So these are inverse functions. So I'm going to rewrite this just as e to the y equals x. All right. Are y'all okay to keep going?
Yes.
All right. So, take the derivative of both sides. Well, what is the derivative of e to the y with respect to x?
Oh, why?
It's e to the y times y prime, right?
Yeah. I believe.
That's what we just got finished doing.
Yeah.
And what's the derivative of x? 1. So y prime is going to equal to 1 over e to the y. And I want to know what y prime is, right? But I actually want to know what y prime is in terms of x. Well, what do I know right here? I know that e to the y is equal to x.
Yes.
So y prime is going to be 1 over x. So now let's think about this as far as our derivatives are concerned. d dx of the natural log of u is 1 over u times u prime. The 1 over u comes from this, so it's 1 over u times u prime. So if I want to know what the derivative of the natural log of 2x is, it would be 2x is in the place of u, right? So it's 1 over 2x, then times 2, which is 2 over 2x, which is 1 over x. Do any of you have a question for me yet? Okay. Usually at this point, people say, is the answer always 1 over x?
I have a question.
What's your question, Kim?
Is the answer always 1 over x?
Let's see. All right.
I'm so excited.
So-
Joy.
Let's look at the derivative. You deserve a Nutella biscuit for that.
Yes, I do.
All right.
Yes, I do.
Yes.
Let's go with the natural log of x squared. Okay? Well, what is the derivative of the natural log of x squared? 1 over x squared, right?
2x.
Times the derivative of x squared, which is
2x.
2x. So we get 2x over x squared, which would be just 2 over x, right? Here comes one of my favorite ones.
Okay. Oh.
So it's not always 1 over x.
You are correct. It is not always 1 over x.
Well, here comes the question.
I thought it was a beautiful question.
Hey,
All
I have
right.
a question.
Go ahead.
Take the derivative of x squared.
Oh, the answer is just going to be 1 over x and 2 over x?
Let's
Or
see,
is it
Carl.
3 over x?
What is the derivative of e to the sine of x?
Whoa, we got rid of the natural on that. Okay.
No. I'm sorry. It should be natural log of sine x.
That means
Or-
it's coming.
I was like,
Well, let's make it the natural log of cosine of x
oh, okay.
instead. It's going to be what?
1 over cosine x times negative sine x.
So that becomes negative sine of x
Tan of x.
over cosine of x, which is
A negative tan of x.
negative tangent of x. Y'all, put a big old star beside that problem right there. Because we are going to look at that again second semester.
Now here comes
Huh?
the
Why is
question.
that your favorite?
Because it becomes its own trig function,
I don't know.
negative tangent of x. I mean, there's not a tangent in anywhere in this. There's not a tangent anywhere in this problem, but it pops up. But no, it's also because what we're going to see happen to it second semester.
I'm not doing that.
Second semester, we talk about antiderivatives, and I'm going to say,
Our band director was talking about that this morning.
sweet. Who is your band director, Mr. McAdams?
No, he's a new guy.
Okay, I don't know him. All right. Anyway, are we okay here? Okay. Now, there's one last problem that I want us to look at. Can I erase this stuff?
Feel free.
Okay. Now,
You're recording in all this, correct?
this is a problem. Y'all pay attention. This is a problem that does not pop up very often in calculus. But it usually does pop up on the AP test. So the problem is not a hard one to work, but it's just a matter of remembering it, because we will not be using it really. Once we get finished with this lesson, we won't be using it again until, all of a sudden it pops up on the AP test. So, but it's y equals, and I'm just going to put 2 to the x here. Now, what this does not equal to, y prime does not equal to x times 2 to the x minus 1. It is not a power rule. It is not a power rule, and that will be on a multiple choice question. That would be one of your
Incorrect answer.
incorrect answers. Yes, distractors is what they call them as a technical term. So, how do we solve this out? That is a good question you just asked. I think Kim may have asked it, because Kim is known for her good questions. So, again, let me take the natural log of both sides here. So I've got the natural log of y equals to the natural log, that's horrible, the natural log of 2 to the x power. Bless you. Which I will rewrite, again, have not done calculus yet. It's the natural log of y equals x times the natural log of 2. Do y'all remember that from logarithms? It's called the power rule for logarithms, which is different from the power rule in calculus derivatives. It just says that we can take the exponent and pull it to the front of the logarithm. You okay? What's wrong, Margaret?
Draw a scribble. Does that look like an N to you?
It looks like it's L at this scribble.
Y'all are gonna hurt my feelings one day.
I'm not mad at your
She
handwriting.
said, what if I can't draw a cursive N? And I said, just draw a scribble.
Yeah, that's all I do.
We're good.
Okay.
If that's
Did y'all learn cursive?
Yes.
Y'all never.
Yes, in
Okay.
second grade.
Yeah,
Second
that's
grade you
how I
did.
was
Third
second
grade.
And that's the last time you used it. Okay. Well, you use it in my class. All right. Can I keep going?
Yes.
Yes.
Okay. Now I'm gonna rewrite this side as the natural log of 2 times x. Now it's time for calculus.
Yay!
What is the derivative of the natural log of y?
Would it be
Say it again.
x squared?
1
Over y
y
times y prime.
times y prime
You did that.
I did do that.
equals. Now, looking at the right hand, I need y'all's attention up here. Looking at the right hand side, the natural log of 2 is not 1 over 2 times the derivative of 2. The natural log of 2 is well, actually it is. The natural log of 2 is a constant, and the derivative of a constant is 0. So I've got the constant multiplier rule happening here. So the constant multiplier rule says it's this times the derivative of this, so it's just the natural log of 2. Are y'all okay with that?
Okay.
If this had been 3x, what's the derivative of 3x? 3. So it's the natural log of 2x, so its derivative is the natural log of 2. Okay? Now, I'm trying to solve for y prime, right? That's what I need to know. So y prime is equal to y times the natural log of 2. And what is y? 2 to the x? So the derivative is 2 to the x times the natural log of 2. Or you could think about it like this. If I have y equals b raised to the x power, y prime is b to the x power times the natural log of b.